Hey Super Scientists, we're looking at geology and we're going to be reviewing really quickly for your EOG. Remember, this is not comprehensive. It is not every single thing that we talked about during the school year, but it is the main topics. So looking at types of evidence, rocks are going to be one piece of evidence that can go through weathering, erosion, and unconformities. So there's a lot of different ways that rocks can change. Fossils are another example, and fossils are going to be from living organisms. So they are going to be formed from once living organisms, and that'll show us how Earth's climate has changed. Ice cores are going to show how the atmosphere and the climate have changed. Here's a couple different vocabulary words. So index fossils are fossils that help to tell the relative age of different types of rock. And so those organisms that are index fossils were widely distributed and they lived a short amount of time. They lived during a specific time frame. Trilobites are an example. Ammonites are an example of index fossils. Unconformities are going to be caused by erosion. It's where you have really old rock that comes in contact with new rock. And so this is due to erosion. The law of superposition says that the oldest rock layers are going to be at the bottom and the youngest rock layers will be at the top. Uniformitarianism, the processes that shaped Earth's surface in the past still shape Earth's surface today. Types of weathering. Physical, which is sometimes referred to as mechanical weathering. So that is physically using force to break down rock. Ice wedging, pressure, abrasion, those are all examples. Chemical weathering is chemically breaking down the rock. So using chemical processes or acid rain, for example. Rust, oxidation is another example. Looking at this sedimentary rock layer, or this stratigraphy, it does have some, a few igneous rock layers in here. We've got some extrusions, so that is lava that's been deposited, and we have an intrusion right here, letter V. So putting the rock layers in order from the oldest to the youngest, so the oldest is going to be at the bottom. So A, and we're just going to look at site 1 right here. So A would be the oldest, and then B, C, D, E, F, G would be the youngest. And that's because of the law of superposition. Now, if we look at this one at site 2, so we're going to have layer W as the oldest, and then X, and then Y, and next is going to be V, and then Z would be the youngest. And we know that Z would be younger because the intrusion only formed up to this point in letter Y. And remember, intrusions are always younger than the rock layers that they cut through. So that is our answer number 5. Intrusion is always younger than the rock that it cuts through. Number 6, the relative age of extrusion E. Is that younger or older than the sedimentary rock layer F? Well, E is below F, and so if it is below it, then that means that it's older. Number 7 was one possible explanation for why site 2 does not have as many layers as site 1. Erosion, perhaps. Also, they may not have formed. Number 8, if scientists found a fossilized fish in layer B, which we have right here, what could you infer about the environment during the time that it was formed? Well, if you find fish or any other aquatic fossils, then that indicates that that area had to have been underwater at one point. So you have multiple species, multiple types of aquatic fossils here, so that indicates that this area was underwater. Geologic timescale. So Precambrian time makes up 88% of Earth's history. This is from the formation of the Earth 4.6 billion years ago, and that goes up until the Paleozoic era. Paleozoic era, paleo means old or ancient, and zoe is animals. So we had lots of invertebrates, lots of organisms that were living in the water, and it started off with the Cambrian explosion, which is where you have a lot of biodiversity, a lot of different types of living organisms were evolving at that point. The Mesozoic is the next one. Meso is middle, zoe animals. So the middle animals, it's the age of reptiles, and it's called the age of reptiles because the dinosaurs were the dominant life form. And Pangea, which had been forming throughout the end of the Paleozoic and at the Permian, and Pangea begins breaking up and splitting apart. Cenozoic, the age of mammals. The Cenozoic is our current era. There were several series of ice ages. And of course, Homo sapiens, we have humans during the Cenozoic. That is our current era. What marks the end of each era? Mass extinctions. And remember, mass extinction is where a lot of different species end up dying off. 11, which era are we living in right now? Cenozoic. Relative age versus absolute age. So relative age is going to be the age of rock compared to other rock around it. So it's about how old it is based on evidence that is around it. And the absolute age is going to be the birth date of the rock. It's the age since that rock formed. What type of rocks is relative age going to be used on? It's going to be used on sedimentary rock, and that's because sedimentary rock is made of a lot of different particles that have been compressed together, and so all those particles may be different ages themselves. So we have to use relative age for sedimentary rock. Absolute age is going to be looking at igneous rock because you can find out exactly when igneous rock formed based on the particular isotopes that are in those rocks. How to determine the age. So there's a lot of different ways to find relative age. You can use law of superposition. You can look at extrusions and intrusions, and that intrusion and extrusion would be made of igneous rock, and so that's why you can compare it to that. Index fossils, unconformities, you can use faults. So there's lots of different types of ways that you determine the relative age of rocks. Absolute age is going to be using radioactive dating, and these are two different methods, carbon-14 and uranium-238. 13, how could continental drift explain the distribution of the same type of fossil in two continents that are now separated by oceans? So if the continents were together, then the organisms would have been able to move around on the land, and then when those continents or those land masses split apart, then they would have been geographically isolated. They would have been separated. So if the continents were once connected, that would explain why you had the same type of fossil on different continents. 14, in what types of rocks can fossils be found? Sedimentary rocks. How do fossils form? So something will die. So a fish, for example, would die. It gets covered by sediment, and that sediment will preserve the shape of the organism over time. The different rock layers and sediments would be deposited on top of it, so it would all kind of be compressed, and that would help to preserve the shape of the organism in the rock layer in which it was deposited. 15, what do scientists think caused the mass extinction that killed off the dinosaurs? An asteroid that hit the Earth.